Now, see, we started with the Newton's third law. Not audible.
Ma'am, your voice is not clear.
Now, class, tell me, is it audible now?
Yes.
Okay, good.
Yes.
So yes, we were discussing the Newton's third law of motion. So basically, three laws we have discussed. First law was the law of inertia, that a body will not change its state until and unless an external force is being applied on the body. All right. Second law said that this external force is directly proportional to change in momentum. So we have F external is equal to dt over dx, which was the ME basically. Now the third law was based on action and reaction. Now what is meant by action? What is meant by reaction? This says that to every action there is an equal and opposite reaction to it. So these are the things which we were discussing, and Newton's third law also we started with. Now one example was left, that was the case of a person walking on road, and that example also comes to write in the exam. So let me discuss that. See, force that acts when a person walks. Simple figure we are going to draw. See, suppose this is the walking surface and the person here is walking. All right. Now, what all things act here and what all things come into action over here? We are concerned with that. All right. Now, look, when the person does this heel strike, means when the person's heel strikes on the ground, then what happens? A force is exerted on the ground. When the heel is struck on the ground, a force is exerted on the ground. Force on the ground. Now, according to Newton's third law, if there is a force exerted on the ground, so an equal and opposite force will be exerted on the ground. Means exactly equal and opposite force will be exerted. So we'll get a force backwards same. Which force is this? Reaction force. This is the reaction force of the ground. So this is reaction force of ground. Ground has sent this as a reaction force. One was the action when the heel strike was done. Now this is the reaction. So action and reaction, these are making it complete. So action means the heel strike which is done. Reaction means the reaction force on the ground. Fine. Now, see, this is reaction force which is R. Apart from this, there are other forces also which are acting. Downwards, this is the gravitational force which is acting, which is mg, right? Gravitational force is acting, which is mg. And above, a normal reaction will also be there, right? Because there's a contact which is being made, and contact forces always lead to this upward normal reaction. Now, if we say there is this angle, which angle? This angle is theta. Yeah. So what we do, we are going to resolve the forces. Reaction force is in just a random direction. We require a proper angle, and we are not getting a proper angle through this reaction. So what we are going to do, we are going to resolve this. So basically, when you are going to resolve the reaction forces, one is our cos theta along the x-axis. Wherever you have this x-axis, why? Because theta is made with the x-axis. So this part becomes r cos theta, and perpendicular to it becomes r sin theta. Now class, what are the functions of these? This is very important to me. So our cos theta basically helps us to move. This is what? This is Fg, which is the gravitational force. This is the gravitational force, right? Downwards mg. R cos theta is basically making us help to move. Forward propulsion, right? This forward throwing of us ahead, forward propulsion is being done by this R cos theta, which is acting backwards, right? So this is pushing us. Mainly, this is the force which is pushing us. So this actually helps us to move. And then we are left with this R sine theta. What does this R sine theta do? R sine theta, see, this balances the wave. Normal reaction alone cannot balance the wave. So there will be a tumbling which will occur. You will fumble on the ground. So that's why this R sine theta helps balance the wave. So R sine theta, this helps balance the weights. So this is how whenever you walk, action reaction occurs. Now, why only we are discussing this example? We are discussing this example because this has been repeating itself a lot. And one more thing, whenever you are also getting a question on action reaction, you should mention this example by yourself. Okay, write down this, then I'll start with other things. Impulses left here. After this, I'll start with impulse. Write it down and mark this important class.
Done, ma'am.
Okay, so let us start with impulse. Now, what is this impulse? Impulse means, see, if a ball is coming and the batsman hits the ball, so that duration when the ball is in contact with the bat, how much is that duration? 1 second, 2 seconds, 3 seconds, 4 seconds, hours, 1 hour, 2 hour, 3 hour. Mainly a short duration, a long duration. Yes,
A very short duration.
very short duration. Correct. When the ball hits the bat, that is such a short duration. See, ball is coming and the bat is being hit. That time when the ball is in contact with the bat, that is such a short duration. But there's a force which is being exerted. So if a force is being exerted when the contact is there or whenever a short duration is there, that is known as impulse and nothing. This is what is meant by impulse. So when a bat strikes a ball, when a hammer strikes a nail, that duration, because we immediately lift up the hammer. So forces which act for very short duration of time, those are called as impulse. Like this is a good graph. This shows the duration. This is delta t, shows the time duration. Means nothing, nothing, nothing. Immediately a very high pitched and a long force and then nothing. Because this time is very short. So this graph is a little important. It can come because the graph is different. So how do you calculate impulse force? See, whenever you have impulse calculation, just multiply the force with time. It's also a vector quantity and force is also a vector quantity. So yes, it is the total impact of impulsive force. It is the product of average force and the time of contact. So I shows the impulse, F shows the force, T shows the time, duration, and one thing, this duration is very short. Now, delta P over delta T or dP over TP, this is dt, this is what? Change in momentum, right? Change in momentum. So this is the time duration, change in momentum over a shorter period of time, very short period of time. That is what is meant by average force. Now, when you are having this concept of this average force, delta P over delta T if you're writing, dP over dt if you're writing, if we substitute the same thing in the impulse formula, see, I is equal to F into T. If F is equal to P by T, so I will be F into, F we are substituting. So instead of force, we will write P by T and this is the time. Means impulse can also be written as change in the momentum. This is the change in the momentum, delta. So direction of impulse is exactly same as the force And can anyone tell the SI unit? This is the formula of impulse. Can anyone tell the SI unit?
Newton second.
Newton seconds. Perfect. It was easy. Why other students couldn't answer? Newton seconds. Newton for force, seconds for time. Write down this
Done, ma'am.
Yes, now let us solve this question. So basically, see, There are two questions that we can practice. One horizontal, another one will be similar question, but angle will be there. So this one I'm solving right now. I'm giving you time. The next question you will rather. See, 5 kg ball is coming directly with 10 meter per second velocity, and then 5 kg ball is bouncing back. So on that it is 30. So when the ball came, this is the mass and this is the velocity, right? Mass is 5 kg, velocity is 10 meter per second. So velocity is 10 meter per second, mass is 5 kg. Now, see this question, just the difference is that this question is horizontal and angle one you will be solving. This I'm solving, angle portion will be 10 meter. So see what will be the momentum. This is, let's say P1, this is P2. So change in momentum will be P2 minus P1. Now one thing class, both are in opposite direction. So take one direction as positive and take the other direction as negative. Let me take the right as positive and the left will be negative. So right means this is positive, this is negative. So delta P, P2 is minus 10 into 5. Or let me write down the momentum separately. What is P2? P2 is 10 into 5, which is 50, but this will be negative, right? And P1 is 10, this is minus 10, that's why. And this is plus 10 into 5, so it is 50. Now, when we are calculating the change in momentum, P2 means minus 50, minus P1 means 50, that is minus 100. Now, this is exactly the change in, see, first part. Impulse is the change in momentum. So, impulse is equal to minus 100 Newton seconds. This is the first part. Now it is saying if time is 0.2 seconds, what is the force? It's saying if time is given as, see, time is 0.2 seconds, what is the force? So see, I is equal to F into T. So force from here is equal to impulse divided by time. Impulse is minus 100, time is 0.2, which is equal to minus 500 Newton. This is the, write down this question you all are going to answer. here angle is mentioned here. So we directly I can see your answer is wrong because there is no.
Ma'am, your voice is not clear.
Okay, is it audible?
Yes, yes, ma'am. Now it's clear.
Okay. I was saying that see, abhi directly we can see your answer is incorrect because theta is not there. So that is the issue. Here in angle, you'll directly get theta. See, this is a velocity which is acting. Now, you will resolve the velocity into two directions. If this is theta, this will be theta. So this becomes v cos theta and this downwards will be v sin theta. Similarly, this and this. This is theta, so this will be theta. This becomes v cos theta, downwards becomes v sin theta. Right? Now, look here, the net velocity along x-axis. Let's say this is positive, this is negative. So v cos theta minus v cos theta, this becomes 2v cos theta. Now, vy. Let's say here both of them will be positive because they are in the same direction. So v sin theta minus, this is positive. So v sin theta cancelled. It is 0 this time. Right? This is 0 this time. Now look, what is the change in momentum? Change in momentum is mass multiplied to the velocity 2v cos theta. So delta P is going to be 2mv cos theta. And what is impulse equal to? Impulse is exactly equal to this, so 2mv cos theta. This will be the answer. Okay, write it completely.
Done, ma'am.
Ma'am, done.
Okay, class, now see, in this fully mass system is our next topic that completes with impulse. We'll be getting the after class assessment based on it only. Now, what is pulley mass system? Basically, a rope is there which goes over the pulley and it comes down. So both the blocks are held. One end is fixed towards the rigid part, and the other portion is there. The free end is there towards the masses. All right. So one mass M1 is there, second mass M2 is there. Now, there's a force, tension. Tension force is there. So this is, since we are talking about forces, so this force is equally important as that of the other forces which are present. So what is this tension force? This acts on strings. Now, strings or ropes, thin, very thin threads, strings, ropes, like this. And it always acts away from the body. So this is a rope which is there, so away from the body will be there. If this is the body there, away from the body will be this. This is what is meant by tension. Now, downwards, we'll be having gravitational force. Now, we know force of gravity is mass into acceleration due to gravity. So, this becomes m1g. This becomes m2g. This is the case. Now, suppose, let's say m2 is heavier. So, acceleration, this is going downwards with a acceleration. And this is a little lighter. So, this is going upwards with a acceleration. Okay, this is it. Now, before everything, you should know how to draw the free body diagram of it. Let us write down the free body diagram. Suppose this M1 block is present. What all forces have you drawn on it? Tension upwards, M1G downwards. That's it. So this is called the FBD, means the free body diagram. I have M2 with me. Tension upwards, M2G downwards. So this is the FBD. For the first figure, this is for the second figure. This is how you draw the free body diagram. All right. Now look. Now remember one thing, direction of acceleration is taken positive. So all the forces acting along the direction of acceleration will be taken positive, and all the forces taken in opposite direction as that of acceleration will be taken negative. Okay, along acceleration positive. Now our task is that we want to find out this mass of body into acceleration. Simply we know one thing, F is equal to ma. We just know it. Mass is given, acceleration is a. What is the net force for each of them? See, let's write the block 1. What will be the net force? 1 is T, 1 is M1G. How do we write the net forces? They are in opposite direction, so they'll be subtracted. So will it be T minus M1G or M1G minus T? Can anyone answer? I've told you also how to find out. T will be positive or negative?
Negative.
Why negative? For this
It is
block 1.
acting.
For this block 1, just for this block 1.
T will be positive, and for block 2, T will be negative.
Other T will be negative. Yes. Just don't go by this T thing. Just go by one block. That's why FBD I've told you. Free body diagram means you're focusing on the first block only. Forget this. Don't look from here. You have to draw the separate body like this. Okay. Now acceleration is upward. So that's why our tension is positive. This was the logic only, Abhi.
Yes.
So acceleration is upward. So T minus m1g will be the net force. Here m2g minus T will be the net force. So what will be for our block? T minus m1g. This is the net force. Net force is equal to what? Mass into acceleration. This is equal to mass into acceleration. T minus m1g is equal to m1 into A. This is our first equation. And when we are talking about block 2, that time we will have m2g positive. Why tension negative? Because acceleration is directed downwards. So this side is positive, this side is positive. Understood? Now m2g is acting downwards because acceleration is downwards, so this is positive. Tension is now negative, minus 10. This is positive, this is negative, is equal to mass into acceleration. This is equal to mass into acceleration. So second equation. This is how you have to write the equations. Now you can solve it. That we'll see through this question only. First start copying it from here.
Done. Done, ma'am.